Today we're going to cover one of the most important themes in pre-calculus, which is this idea of the family of functions, and the reason it's important is it's not going away. We're going to keep adding family members all year. We've already learned about a few of them. So what we're going to do is we're just going to get rolling, and this is going to be a lot of more information than it is processes today. Okay, we're going to kind of organize some of the things we've learned today. So let's start off with our first family member. Our first family member in the family of functions is the constant function. And we don't need to write out function every time. We're just going to say it's the constant function. And that is the function that looks like f of x equals c. When I say c, I mean just a regular old number. Something like, for example, f of x equals 7. Okay? That would be what we call a constant function. And if you remember, f of x is the same thing as y. So if I have y equals 7, for all of these you want to have a graph because it's going to be very important as we go through the year for you to have a mental image of all of our family members. A constant function, 6, 1, 2, 3, 4, 5, 6, 7. Okay? This function is a horizontal line that goes through 7. Okay? So if you have the constant function, it's always going to be horizontal. What could I say about its slope? What's the slope of every constant function? The slope will always be 0. Always 0. All right? What would the domain, we're going to try to put this down for nearly all of our functions. What's the domain of this function?
Any number.
Isn't it all of them? Negative infinity to infinity. All the real numbers. There's no place where it is undefined. What's the range? Now this one's a little bit trickier. Doesn't the range depend on what it is? Remember, the range is the y values where it exists. So if I was looking at f of x equals 7, what's the only y value where it exists? 7. So if we want to put the range is just whatever that number is. So let's just put c. Okay, the range is going to be whatever that number is. That's the only place where it exists. So the constant function is pretty easy. By the way, we just finished talking about odd and even functions. Is this function odd or even? Isn't it even? Isn't it symmetric about the y-axis? This is an even function. Some of them, we're not going to worry about. Some of them are not as obvious, or they can change. But a constant function can't change any. All right, let's go to our next family member. We're going to kind of move up from the bottom up. The next family member is the linear functions. Linear functions are the ones that are in the form f of x equals mx plus b. And you should have a mental image, all right, of what a linear function looks like. Obviously. Now, they don't all go through 0. Some of them do. So we're just going to draw a straight line of some kind. Okay, it doesn't matter. Because that's what a linear function looks like. It looks like a straight line. It has a y-intercept. It has a slope. It has all those things that we've talked about. Now, let's say something about it. What is the domain? Isn't it everything? Negative infinity to positive infinity. What's the range? The range is also everything. It's also negative infinity to infinity. Okay? Now, it's a little bit different talking about even and odd. That one, the graph that I drew over there, would that function be even? It would not be. Would it be odd? No. So we could say that it is neither, I guess we could put these little points in bullets, help us organize. It is neither even or odd unless what? Is there a time that it could be odd? When it goes to the origin. Unless b equals 0. Okay? If it goes through the origin. And at that point, we would say then it is odd. Okay? So there's our second family member. Our family is growing. We have another family member we've already met this year and invited over for Thanksgiving dinner. That would be the quadratic family. Hopefully you fed them, did not put them out on the porch and shoved food under the table to them. The quadratic family member, that is the function that is ax squared plus bx plus c. And we've worked with it enough this year, we should all have a mental image of what the quadratic looks like. I'm going to sketch what would be called the parent. When you hear me say granddaddy or parent function, I'm talking about just the regular old function that has no transformations. This particular graph right here is just x squared. But as we know, those quadratics can be all over the place. Okay? A quadratic, could be down here. Don't put this on your graph, it'll get all messy. It could be over here. It could be upside down. Okay, quadratics can be everywhere. All right, all I drew was the parent function. So let's make some statements now. What's the domain? Everything. Okay, that's nice. The range, though, how can we say this? For the parent function, it would be 0 to infinity. The better way to say it probably is if it is isn't that one that I drew concave up? Did you guys talk about concavity last year? If it is concave up, then its range is the minimum y value up to infinity. Whatever, and I'll put a little red mark here, what I mean by the minimum. Okay? The minimum, the low spot, we calculated those the other day. Now notice I said minimum y value because we're talking about range. If it is concave down, that means upside down, then it would be, now let's be careful here. Remember, we're always coming from the bottom up. So it would be from negative infinity up to the maximum y. All right, so it just depends upon which way the function looks. And how about even and odd? Well, it's even if it's f of x equals x squared or f of x equals x squared plus or minus c. If there's no middle term, okay, if you don't have the x term in the middle, basically, then it's even. Other than that, it's not odd. All right. So if it is not one of these two scenarios right here, then we would say that it's neither. All right. All right. The next family member. It's like going to the maternity ward at the hospital. Babies being born everywhere. Oh, I guess I need to give it a name first. The next family member is the cubic. And we've only worked with these just a little bit. the cubic function is f of x equals x cubed. That's the parent or the granddaddy form of it, but just like quadratics, they can look a lot different than that, okay? The parent cubic function looks like this. All right? But these can become much more complex than this. You know, you can get a cubic that looks like this. That's also a cubic. All right? And that cubic, the graph of a cubic like that, now I don't know exactly what this graph looks like, but when you start complicating matters with some of these other terms like this, then cubics start looking like this. Okay? So you need to have both graphs in mind when we talk about cubics. All right? Both graphs are a cubic. It just depends upon the form of the cubic. If it's just regular old x cubed, like this one, and that could even be, you know, it could even be 7x cubed or negative 3x cubed or something like that. If it's in that form, it's going to look like this. But as soon as you start adding in all of these other terms, cubics start looking like that curve right there. All right? So, the domain is easy. Domain is negative infinity to infinity, because we can cube anything. The range is easy. That's everything. Okay? And as far as evenness and oddness, if it is the parent function, what I would call the base function up here, this one, then it's odd. Okay, so we would say it is an odd only if the base or parent function. All right. It's odd only if if it is the base or parent function, or we can say goes through the origin. This form right here could be odd if it goes through the origin. All right. Okay, our next family member, and you've seen a couple of these the last couple days, is the square root family member. And that function, the base function, is the square root of x. And the parent, the graph of this parent function, or the base, looks like this. That's the square root function. Now, just like the quadratic function, this thing can be moved all over the place. All right? If I had, we're going to learn about transformations here shortly. Just a real quick example. If I had f of x equals the square root of x minus 4, then this square root function gets moved over 4 units and looks like that. Okay? And we're going to learn about all those transformations shortly. But that does affect tremendously the domain of the function. Okay? So, the domain, and I'm just going to say for the parent function. Okay, parent only. The domain for the parent function is 0 to infinity. Because what would the domain of this one down here be? The domain of this one, wouldn't it be 4 to infinity? Right? So it changes. And these things can be flipped around backwards. You know, a square root function can also look like this, which would change its domain. All right, these things can be flipped every single direction, which means it's kind of hard for us to make a good domain statement for all of them. All right? Now, what would the range be for the parent function? Wouldn't it be 0 to infinity also? Okay. Now, these are, one other thing about these is these can also be moved up or down. All right, so, you know, we can have, like I said, these square root functions can be everywhere. I could have a square root function down here, like this. Boom. I mean, they literally can be everywhere. So we're going to learn about those places where it can be, and all of that affects what the range and the domain is. All right, so we're not going to get real complicated with what we say about domain and range. By the way, these are neither even or odd. There are some cases, well, no, there's really no place where these could be even or odd because they have to be symmetric about an axis, and they're not. They usually only exist on one side of the axis. All right. The next family member is the reciprocal family member. The reciprocal family member is one like this, f of x equals 1 over x. Okay, or we could also think of it as, and I'd like for you to add this, rational. Okay, and we'll do a whole unit on rational functions, but this graph looks like this. Okay, that's what is known as the reciprocal or the base rational function. And you'll notice it has a big hole in the middle. This thing is called an asymptote, and we're going to learn a lot about asymptotes later on. For right now, though, the domain would be everything but 0. Negative infinity to 0, union 0 to infinity. And the range would be the same thing. Negative infinity to 0, union 0 to infinity. We have one more function that we need to talk about, but we're going to have to do that in our next session of notes, and that is the greatest integer function. Okay, and tonight in homework, if you see this one, that's the greatest integer function. And we're going to run out of time before we can talk about the greatest integer function. But it is basically called a stair-step function. Okay, something like that. And we'll stop there for today.